This is an important video about higher order derivatives. It's important because we're really not going to go over this in class, but you are required to know this. Um, it's not all that important to go over in class because it's pretty straightforward, but you have to really watch this to get the notation down and to see the process. So we already know the first derivative has all these different notations. So the first thing we're going to talk about is notation. This I call Newton notation, which it really isn't, but we'll call it that. This is Leibniz. If you're asked to take the second derivative, instead of y prime, you'll just write y double prime. If it's in Leibniz notation, this gets a little confusing. It's d squared x over dx squared. There is a good reason for that. I can show you at some later time. Just won't do it now. The biggest thing about that is to recognize if you're asked to find d squared y over dx squared, you know that means second derivative. And then third derivative would be y triple prime or d cubed y dx cubed. At some point with these primes, you're going to have to stop writing them, or you're going to have something like this, and you don't want that. You don't want to count the primes. So for the fourth derivative, you just put a little 4 in parentheses, and so on. For Leibniz notation, you can just keep those numbers going up. So that's the notation. The process. And by the way, I didn't mention it, but we will use higher order derivatives in this course. So there will be a reason for this. You will see. So this question says determine the second derivative of this function. So to do a higher order derivative, you just do that many derivatives in a row. That's it. So the second derivative would mean take the first derivative and then take the second derivative, and that's your answer. So first, we're going to take the first derivative of this. I wouldn't use the quotient rule because it's much more complicated than just the power rule. So the first derivative is negative 6x to the negative third. Normally, we would go ahead and simplify this, but if you're taking the second derivative, it's always easier, or usually easier, to take the derivative of the unsimplified form. So since we know we're going to keep moving on with derivatives, just keep it unsimplified, because you can see this is an easy derivative. So this is the second derivative. You just take the derivative again, 18x to the negative 4. So I'm done with my second derivative. Now I'm going to simplify. If you want to check these, you can go to Wolfram Alpha and just type in what is the second derivative, or find y double prime probably would work. But that's it. So try this one. It's pretty simple, but just give it a shot. Pause if you need to. Okay, so if you pause and you're back, here we go. This means the third derivative. So you take the first derivative. I'm not going to write it in Leibniz notation just because it's more writing. Now we go to the second derivative. Now we go to the third. I'm going to simplify because I can factor out negative 12. And there's the third derivative of that function. Simple. The only way it would get hard is, or difficult is, if the function is more difficult. So if I said find the second derivative of this, you would just use the quotient rule, and then you may have to use it again. So I guess we'll do that quickly. So, let's find y double prime. Y prime would be bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. I am going to simplify this a little bit because I don't want to go through the whole quotient rule here. So we have x minus 1 minus x minus 2, which would be really come down to negative 3 over x minus 1. So really that wasn't too bad. Now the second derivative, you can go back to the quotient rule. I guess we're going to have to. Actually, this is an interesting one because this is going to be a lot easier in the next section. We can't really do x minus 1 squared as is. So I'm going to change this to x squared minus 2x plus 1 so that we can use the quotient rule because this would give us problems here. So the derivative, that's y prime. So the derivative would be bottom times the derivative of the top. Notice the derivative of the top is going to be 0. So I'm just going to write 0. X squared minus 2x plus 1 times 0 minus the top times the derivative of the bottom, which is 2x minus 2, all over the bottom squared. Now, the bottom squared would be this squared, but we already know the bottom is x minus 1 squared, so it's easier just to write it like this. The bottom squared. We already established that these two things are the same. So now we have, this is a positive 3. So we have 3 times 2x minus 2 all over x minus 1 to the 4th, which is 6 times x minus 1 all over x minus 1 to the 4th, which, this was a good problem, gives you a cancellation, and here's your final answer. So that's where you're going to have to really go through a process with this. Last thing I want to mention before you leave is think about this question for as long as it takes. Without actually going through it, can you figure out what the sixth derivative of this is? So think about that. Maybe if you remember, let me know what the answer is in the chat next time you see me. And that is all.